Okay, okay, so now I'm recording lecture 3. So we start lecture 3 by identifying what is data governance and what is information governance. Sometimes these two terms could be confusing, and you really want to ask yourself, is this data governance or information governance? So we'll get into that. So first, let's take a look at data governance. Data governance deals with compliance, quality, privacy, and security. It also includes communication and awareness, policy and standards, and technology infrastructure. So these are some of the key attributes that data governance handles. So Data Governance Institute defines data governance as a system of decision rights and accountabilities for information-related processes, executed according to agreed-upon models which describe who can take what actions with what information and when, under what circumstances, using what methods. So let's take a look at this definition piece by piece. So data governance deals with a system of decision rights and accountabilities, right? So we are involved in decision making here based on the information, and we are using agreed upon models. That means if there is a HIPAA rule, we follow that HIPAA rule. One of the HIPAA rules could be do not use unencrypted data storage devices, right? That's one of the HIPAA rules. So using encrypted data storage device is a part of data governance. So how data can move from one system to the other? Who can access the data? That is also defined by data governance. So I'm going to skip this slide and see these are the things involved in data governance. One is the people, process, and technology. So it's all about how technology is used by processes and how processes are used by people to implement that particular technology or to use that particular technology. Implement may not be the right word here, I'm sorry. To use that particular technology. Okay. So you have business rules to ensure validity of data and rules associated. You have governance processes, you have audit and control to make sure that the rules are being followed. Someone has to have implementation of the rules, or someone has to perform implementation of the rules and check if that implementation is done properly. So that's important. So then you have information governance. Information governance is a holistic approach, which means information governance is a superset of data governance. Information governance is possible because data governance is carried out properly. So information governance deals with the business needs, while data governance deals with the IT or information technology needs. Of course, you cannot have information governance without data governance. So this is the overall diagram of information governance. You have information security, you have email management, audit, records management, information rights, etc., etc. All right, so that was about data governance and information governance. So let's talk about backup strategies. So in backup strategies, primary site is where is the primary place or the primary server where the data is stored. And there are backups of the primary site, which makes it, a backup site. So many times for huge hospitals, you have huge server farms used to back up data because they are dealing with millions of records, if not at least, yeah, they're at least dealing with millions of records. Thousands of records could be applicable for small clinics. But when you are dealing with a huge hospital network, you're dealing with millions of records. Okay. So you have a primary site and a backup site. Many times that could be multiple backup sites. And backup sites have a mirror image of the copy of data that is contained in the primary site. So that's one of the primary copy technique, is having coordination between different storage sites and coordinating between them. So if this primary site goes down, which is going to be the backup site? That's decided by that particular strategy. And that is decided by the coordinator, where the coordinator decides if this site goes down, then this backup site becomes the primary site, and so on and so forth. So election process, I'm going to skip these because it's not important for you guys. Also, we have the record management or the catalog management process, where a catalog has information on the primary sites, how data is partitioned. Sometimes partitioning is done for security purposes. There could be a horizontal partitioning, where a set of patient data could be stored in one server and a set of patient records could be stored in another server. Sometimes you have vertical partition, where an individual patient record could be split into pieces vertically, in the sense, when I say vertical, we're talking about social security number, address, and phone number being stored in a different server, and diagnostic information of that particular patient stored in a different server. So that's breaking up the data vertically. Okay, so now you know the difference between horizontal partition and vertical partition. So there are catalogs that indicate where the partitions are sitting and how partitions are happening. So there could be centralized catalog, which could be a security risk, where you have a central place, it's like a yellow book. Nobody uses yellow books these days. But back in the days, if you know about this, in the 90s, people used to use yellow books to find out which service is available. Now you just ask Google, and you get the information. So that's how the catalogs work. You have fully replicated catalogs. So where a particular piece or a particular catalog goes down, then you have replication of catalogs, or then even among catalogs, you can break up the information in the catalog in different places and have every piece talk to one centralized coordinator, which leads to the idea of partially replicated catalogs, where you have replication, but at the same time, different pieces are stored in different places. For all this is done for security purposes. So what is cloud computing? Cloud computing is a paradigm of offering computer infrastructure platforms, software as a service, or the internet. A lot of softwares these days are available online. These days, when you buy a software, they ask you, do you want to download a copy, or do you want to subscribe for $20 a month or $10 a month, or do you want to pay $300 for a one-time copy? Keep in mind, your one-time copy might become old in a year or so, and you might have to purchase again. So the smart thing to do is get a subscription. That's how companies make money. They want you to keep paying them all the time. But that's how cloud computing works. It has its benefits. For example, Google Photos. Back in the days, You take a photograph, you have to maintain a photo album. You go to the developer, get your photographs printed, and insert it into the photo album. And after a while, the photo album starts gathering moisture, and the photograph sticks to the plastic screen on the photo album. All those things were in place in the 80s and the 90s when I was growing up, but now you just take the photograph using your phone, and it's uploaded on the cloud so that you can access it anywhere and all the time using your devices, right? That's cloud computing. So this idea could also be used to store patient information, but one has to be careful about security. All right, so I'm not going to go into this decoupling of metadata because it's a computer science concept. So I hope you liked my lecture and you learned something from it. Thank you.